Good morning. It's Wednesday, May 20th. We're at Unit 9, Lesson 6. We are looking at central and inscribed angles today. These should be pretty easy, guys. I think this is easier than the couple that we've done this week, so hopefully this video will be nice and quick for you. Again, you're going to want to, for the Google form tomorrow, have your notes with you, have the formulas with you, make sure that you're working each one out. Make sure you're still using pencil and a piece of paper, not doing everything in your head. It's good to write out your math problems. If you have questions on it, our Google Meet is on Friday. You can join. We can go over whatever you have questions on together. I'm ready. And email me. Okay, so here we go. Our goal today, again, is to look at central and inscribed angles, but you guys already know what those are.
Who knew this guy, 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 who knew this guy.
But let's just review them. So an arc, we've talked about this, and we're just going to quickly look at some definitions of angles and arcs. And again, really quick, an arc, we've already said, is a portion of the circumference or that outer edge of the circle. So we can call that an arc right there. It's just a little piece of the circle. Okay, it's measured in degrees. So keep that in mind because today we're going to be finding missing arcs and angles. So they're measured in degrees. A minor arc, minor always means smaller. So it's just an arc that's smaller than 180 degrees. So actually, if I look here, that purple arc could be a minor arc, but a major arc is an arc that has 180 degrees or more, okay, or greater than 180, not just 180. So for instance, in the same circle up top, if I do that blue there could be considered a major arc because it's clearly bigger than half the diameter. It's more than half that circle. Typically, we find minor arcs, but otherwise indicated we can find major arcs as well. We've talked about these as well, an inscribed angle. So an inscribed angle, let's draw a picture. It's an angle whose vertex meets somewhere on the outer edge. You guys already learned that the inscribed angle is half the measure of its arc it's attached to. So if I look here, just to give you some numbers, if that arc there is, 80 degrees, then the inscribed angle is half that measure. So the angle measure in here is half of 80 or 40. And a central angle is an angle whose vertex goes to the center of the circle. And again, you've got this angle here, which creates this minor arc, this little section here. And you guys learned that for a central angle, it equals the exact measure of the arc. So if this arc here is 50 degrees, then the central angle on the inside is 50 degrees as well, and vice versa. You can go forwards or backwards with them. Okay? So we are going to pretty much use central and inscribed angles for all of our problems today. An intercepted arc, if you ever see that, it's just an arc that is cut by the angle. So exactly what we've been talking about. I actually should take that definition out because it's kind of pointless.
Yeah, now we're talking. Yeah. Ow. Shh.
But if I have this angle here, and again, if I give it a name like angle ABC, then the intercepted arc would be arc AC. It's like the end of an ice cream cone. Okay, that's how I think of it. I always kind of outline my two spots where my angle hits, and then I know my arc connects those two spots. And if this is an inscribed angle, just for example number 2, if this arc was 100 degrees, the angle on the inside is half of that, so this angle in here is going to be 50 degrees. Nice and easy.
Well, I like it. Let's do it again.
Okay.
Some key pieces. If you have a circle, then all of the arcs around the outside have to add up to the full circle.
Circle one.
And they're measured in degrees, so a full circle is 360 degrees. So again, if I have a circle here, and I know that I've got, let me just put a couple in here. If I've got 1, 2, 3 arcs, all 3 of these, no matter what their measure is, they have to add up to 360 degrees, okay? And I can cut up a circle into however many arcs I want, but if I have the whole circle, it's 360 degrees.
How's it, Squidward?
What the? How the? A perfect circle?
We are going to use the following as much as possible to help us solve for either missing angles on the inside that are formed like at a vertex or missing arc measures. So again, just to review, the central angle equals the measure of its arc. The inscribed angle equals half the measure of its arc. All of the arcs around the outside add up to 360 degrees. If you have a diameter, so again, a diameter runs through the center, well then a diameter would give you half of the circle. So that straight angle in here is 180 degrees, and the arc around the outside, it cuts the circle in half. That's what I think I wanted here. Cuts the circle in half, and then the arc measure is 180 degrees because that's half a circle. Makes sense. And we've actually done problems in previous lessons with this already. It's just now more formal. Okay. So look at this one here. We have circle A, and again, it's called circle A because it's got a center at point A. It says, what is the measure of arc BD? Well, first off, see, it didn't give you any numbers. That's okay. What is BD? If you notice here, I'm going to actually get rid of my picture so you guys can see that picture better. There we go. Arc BD, or that, sorry, not arc BD, but that segment right there, BD, is a diameter. So if it wants to know the measure of arc BD, well, if I look over here, from B to D is half the circle, so it's 180 degrees. The next one says, what is the measure of angle BCD? So when I outline that, BCD is this angle here. That is an inscribed angle. Well, this arc here is 180 degrees. The inscribed angle equals half of its arc, so it's half of arc BD. So it's 1/2 of 180, which means it's 90 degrees. So this angle on the inside is 90 degrees. Last one here says, what is the measure of angle DAB? So let's see if I can outline that one. DAB is from here, D to A to B. Well, what type of angle is that? It's a straight angle, and a straight angle is 180 degrees. Okay, so nice and easy. Let's keep going. This is really all we're doing today. No new theorems or anything. We're just looking at these, okay? This one says, explain why the measure of angle X is 100 degrees. So let's look at what they gave us. They gave me this angle here is 50 degrees. Well, if I find its intercepted arc, or like the ice cream on the ice cream cone, there's its arc. If this angle is 50, that's an inscribed angle. That means it's half the arc, or the arc is double. So that means this blue arc here is 100 degrees. And now I look and say, okay, well, attached to that arc is also this angle here. This is not an inscribed angle. At angle X, that is a central angle, and a central angle equals its arc. So now if this arc is 100, X has to be 100 as well. So the reason that X is 100, we're going to explain why, is we're going to say, well, the arc is 100 degrees because it's double the inscribed angle. And if the arc is 100 degrees, then angle X is a central angle. Let me get rid of my face again so I have more room to write. X is a central angle, so it equals the arc measure. So that's how we could explain it, and that's exactly what we did in this problem. We said, okay, we have this 50 here. It's an inscribed angle, so its arc is double. So that's 100. X now represents a central angle. A central angle is congruent or equal to the measure of its arc, so X has to be 100. Notice with explain, I used words. Okay, let's look at this one. This says here, arc BC, so I always label and outline. So arc BC, this guy here, from B to C, is 25 degrees. It says arc CD, so arc CD is here. That is 35 degrees. It wants to know the measure of angle BAD. Well, let's draw that angle in from B to A to D. So I'm going to draw an angle with a vertex, and it wants to know the measure of that angle. Well, BAD is a central angle, and the central angle equals the measure of its arc, so it equals this whole thing. So if the top of that is 25 and the bottom of that is 35, that whole arc is 60 degrees, which means that angle BAD is a central angle and 60 degrees as well. So the measure of angle BAD equals 60. They don't get too much tougher than this. This one's not really tough. We just have to remember some things we've done throughout the year.
Remember your karma.
So this one here says we have circle A, arc BC to arc CE to arc ED, and arc DB is in a ratio of 1 to 2 to 3 to 4. Remember, if we can't set up a proportion to solve, we're going to do a 1x, a 2x, a 3x, and a 4x. So in other words, BC corresponds with the 1. So arc BC, I'm going to call it 1x. And CE corresponds with the 2. So arc CE, I'm going to call it 2x. And ED corresponds with the 3. So arc ED, I'm going to call it 3x. And last but not least, DB corresponds with the 4. So arc DB, I'm going to call it 4x. Now look what you have. They gave us arc BC. And then we took arc CE. And then we have arc ED. And last but not least, we had arc DB. How much of that circle do we have? The whole thing. And all of the arcs around the circle add up to 360 degrees. So let's first find x. We're going to say 1x plus 2x plus 3x plus 4x equals 360. Well, 1 and 2 is 3. 3x plus 3x is 6x. 6x plus 4x is 10x. So I get 10x equals 360. Divide by 10. And I get x equals 36. Well, I don't know what I'm going to have to find, but I'm assuming I'm going to need those arc measures, so I might as well substitute them in, right? So if arc BC was 1x, well, now I'm going to say if x is 36, this is 36. If arc CE was 2x, well, again, if x is 36, 2 times 36, this is 72. If arc DE was represented with 3x. Well, if x is 36, 3 times 36 is 108. And this one here, arc DB was 4x. Well, 4 times 36 is what? 36 times 4, 144. So now I have all the arcs around. Let's see what we can answer. So part A says, what's the measure of angle BAC? Well, let's find BAC. Angle BAC is right here, BAC. That is a central angle. Its intercepted arc is right here. There's the top of its ice cream cone. So it equals that measure. So it's 36 degrees. There's that angle. Okay. The next one wants to know what's the measure of angle DAE. Well, let's find DAE. So D is here, DAE. Again, that's actually another central angle. It corresponds with this arc here, so it equals that arc. So if that arc's 108, then this angle in here is 108. So it's 108 degrees. The next one says, what's the measure of arc DB? Well, we already found arc DB. Arc DB is right here. We did that off the bat. So arc DB was 144. And the last one says, what's the measure of arc CED? So this one has 3 letters, which means you have to go from C through E to D. So let me outline that in yellow. So C to E to D is this arc here. 2 ways to find it. Number 1, you can just add up the 72 plus 180, or maybe you notice that that connects the 2 endpoints of the diameter. So either way, that arc is 180 degrees. A couple more. Let's look here. It says in circle B, AB equals CD. So let's look here. AB, that's this guy. The length is equal to the length of CD. So they're congruent. Notice they didn't give us any angle measures. So this right off the bat might look a little bit tricky, but you have to use some knowledge that you guys have. In other words, if I look here, that's great that those 2 pieces are equal, but talk to me. What is AB also in that triangle? Well, AB is a radius. So let's look. Do we have any other radii in here? Well, sure thing. Isn't BD a radius? So doesn't that mean that if AB has to be congruent to BD, which means that if AB is equal to CD, that now BD and CD are equal? Do you have any other radii? You do. You have BC is also a radius. So look, I've marked all of these. And now if I look at this picture here, I look and see that I have what type of triangle?
We're not talking about this or this. We're talking about this.
It's an equilateral triangle. And how many degrees in each angle? 60. Because remember, a triangle has 180 degrees. It's got 3 angles. If they're all congruent, I'm going to do 180 divided by 3. So each of these angles is 60 degrees. I could actually, I'm not even going to look at what they're asking me to solve. Right off the bat, I'm like, let me find this angle here is 120. How did I know that? Do you see the linear pair? So now I've got some angle measures. Let's see what they're actually looking for. So part A says, what's the measure of arc CD? I always outline my arcs. You notice if it says arc CD, I go from point C to point D, and I'm like, all right, how big is that ice cream cone piece? Well, I'm going to find the angle it corresponds to. So if I take those two endpoints and I find the angle, do you see? There's the central angle. So if this angle is 60, it means this arc is 60. Let's look at the next one. The next one says, what's the measure of arc CAD? So arc CAD, here's C. I'm going to go to A next. That's what it told me to do. And then to D goes all the way back here. That is not the full circle. It's missing how much of the circle? It's missing the 60-degree arc that we just did. So if a full circle is 360, I'm going to take out the arc that's 60 degrees in there. And that means that the measure of arc CAD is 300 degrees. Okay. Last but not least here, it wants to know the measure of arc AD. So here's point D. So I'm going to outline that from A to D is here. How many degrees in that arc, and how do you know why? Well, that's 180 degrees because, again, AD is a diameter here, so it splits the circle in half. All right, here's another explain. So in this one, it's saying explain why x equals 62 degrees. So let's see with some things we know. So first off, they gave us this arc here. Also notice they have this here. What is that again? That's a diameter, and a diameter splits a circle in half. So that means that this entire arc here is 180. Well, if this piece of it is 56, to find this piece, you're going to just subtract. So I'm going to do 180 minus 56, and I get 124. So to explain why, that's what I'm going to start with. And I'm just going to use my colors. I'm going to say the arc is 124 degrees because the diameter splits it in half. Splits. Let me get rid of my pictures so I have more room. In half. And 180 minus 56 is 124. Now, let's look. They want to know why x is 62 degrees. Well, look at this angle in here. If I look at this angle here, and I find its intercepted arc, its arc is this. X represents an inscribed angle. So I would do 124 inscribed angle. You divide it in half, and I get x is 62 degrees. So to finish this problem off, I'm not going to write the whole thing out because I'm running out of room, but I would say next that x equals 62 because it's half its arc, because it's an inscribed angle. And that's why it's 62 degrees. All right, let's find x and y here. So this has got a couple pieces going on. Did it again. Okay, so if I look here, for me, I look at something like this. I'm like, all right, they gave me angle measures. Let me find the corresponding arc measures that like go along with it. In other words, if I have this 86-degree one here, I kind of outline and say, okay, that's this angle here. It's an inscribed angle. I can see that this whole piece right here would be the arc that kind of corresponds with it. Well, the angle equals half the arc, or the arc is double the angle. So if this is 86 degrees, that yellow arc is 2 times 86, which is what? 172 degrees. So that's that arc. Now, I don't know if that's going to help me or not, but let's see. So 86 times 2, just checking my math, 172. Okay. So then I look here and I'm like, all right, well, I think I can find y now just knowing that piece. Look. If that yellow arc is 172, well, look here. See this other arc that I just finished on the other side of it? Isn't that the other part of the circle? So if the whole circle is 360, I'm going to do the 360 minus the 72 to get that pretty green color arc. and that's 188. So this arc here is 188. Well, now if I look at angle Y, if I want to know angle Y here, angle Y is an inscribed angle. And if I outline the two endpoints, it happens to be this intercepted arc that it corresponds to because it's inscribed. I'm going to do the 188 divided by 2. And what do I get? Like 96. How about 94?
You dumb?
Yeah, it's good to divide 8 in half and get 4. That's good. 94. So Y is 94 degrees. Now I could go through that same process to find X, or you have a quadrilateral inside here, a four-sided shape. And all four-sided shapes, their four angles add up to 360. So to find X, I'm going to do X plus 86 plus 105 plus 94, and that equals, inside the quadrilateral, it equals 360 degrees. Okay, so let's see what I get. I'm getting that X is 75 here. So X is 75 degrees. So once I found one of those, once I found Y, I didn't necessarily have to use angles and arcs anymore, but I could have to get that X is 75. Okay, let's find this one. This one wants me to find X as well. So again, you have to kind of look at it!
Look at it! Look at it!
Look at what they gave us and say, all right, how do I find some missing stuff? Well, I look here, and first thing that I notice is the 50 degrees they gave us. And I notice this triangle here. I'm like, all right, usually when they give me a triangle, it's because they want me to use that all the angles of a triangle add up to 180. Well, let me ask you, what type of triangle is this? It's isosceles. Why? Well, because this is a radius and this is a radius, so those two pieces are congruent. Which means if that one bottom angle is 50, an isosceles triangle has two congruent sides and two congruent angles, so this is 50 as well. Could I find this top angle? Sure, 50 and 50 is 100. All three angles of a triangle add up to 180, so 180 minus 100 is 80 degrees. And inside here, this angle now is 80 degrees. Well, that's helpful because if I have that angle, can I find its arc? What type of angle is that? That's a central angle, so it equals the measure of its arc. So if this is 80, then this arc is 80. Ooh, now let's look to find X. X is an inscribed angle. It happens to be connected to this same arc, so as a relationship with this same arc. Well, since it's inscribed, X is half of the arc. So if the arc is 80, then X has to be 40 degrees. Again, like a puzzle. Just keep finding one piece, using that piece to find something else. So that's it. You're done for today. Again, I keep like a broken record.
SpongeBob, the remote control's broken.
Every single time I make a video, join our Google Meets, email with questions, get your work in by Sunday. Okay, we're getting almost done with circles, to be honest with you. A couple more days of it, and we'll be good. All right, so I look forward to hearing from you guys. See ya.